Good day. By the way, I am Jennifer Arena. In this video, I'm going to perform hypothetically and explain to you the principle, requirements, importance of extracting limonene from oranges by steam distillation, its procedure, and result of the experiment in activity 4, which is to obtain pure components from a mixture of organic compounds using steam distillation. The experiment we're going to perform here is the extracting limonene from oranges. First, let me define steam distillation. Steam distillation is a technique used for separating substances which are immiscible with water, volatile in steam, and having high vapor pressure at the boiling temperature of water. It can be used for purifying liquids with very high boiling point. Example, let us consider two immiscible liquids. In the mixture, one liquid cannot mix the property of the other, so each liquid behaves as if others is not present. Therefore, each liquid will show its vapor pressure, but the sum of the vapor pressure will be much higher than the vapor measures of liquid. Hence, the mixture of two immiscible liquid will boil at a lower temperature than the normal boiling point. That's why steam distillation can be used for purifying liquids with very high boiling point. An example of this is the aniline. Now, let's continue to discuss its principle. The method is called distillation if water is used as one of immiscible liquids. It also used for purifying liquids which decompose at their normal boiling point. Example of this is the glycerol. Used for steam distillation, also used for separating organic compounds from plant parts. Example, lemongrass oil and eucalyptus oil. Steam distillation process works on the principle that when a mixture of two or more undissolved liquids are heated, while ensuring what the surfaces of both liquids are in the contact with the atmosphere, the vapor pressure exerted by the system increase. Example, the boiling point of bromobenzene is 156 degrees Celsius and the boiling point of the water is 100 degrees Celsius. But a mixture of the two boils at 95 degrees Celsius. Thus, bromobenzene can be easily distilled at a temperature of 61 degrees Celsius below its normal boiling point. Now let's have the basic importance of steam distillation. Steam distillation is used to separate heat-sensitive components as what I have discussed to you earlier. Steam is added to the mixture, causing some of it to vaporize. This vapor is called and condensed into two liquids fractions. Sometimes the fractions are collected separately or they maybe have different density values, so they separate on their own. Example, distillation of flowers to yield essential oil and a water-based distillate. Next, steam distillation is employed in the isolation of essential oils for use in perfumes. Example, a certain plant or flower that we're going to distill para gamiton nato og perfumes or kanang haplas. Steam distillation also is an important means of separating fatty acids from mixture and for treating crude products such as oil oils to extract and separate fatty acids, soaps, and other commercially valuable organic compounds. So there is a history about steam distillation. There is a Persian chemist named Ibn Sina, or also known as Avicenna in the West. He is the one invents the steam distillation. He invented it for the purpose of extracting essential oils which are used in aromatherapy, drinking, and perfumery industries. This image shows on how we are going to perform the steam distillation. You can see here a lot of glassware and apparatus like Bunsen burner, round bottom flask which contain the water, the Florence flask which contain the compound to be distilled, then the conical flask which is the contain the water and the distilled liquid. Bunsen burner is used to heat up the flask. That blue one is the water. There is a tube inside it, which is the safety tube. Gipainit na tong flask kay ma-produce yung condensed water vapor. Then next to the orange one, which is inside the Florence flask, mao na ang compound nga ato ang i-distill. Then lastly to the conical flask, you can notice that there is yellow and blue. The blue one is the water and the yellow one is the distilled liquid. So let's continue to requirements. These are the chemicals that we're going to use in this experiment as per specific requirement. Number 1, bromine water, no more than 0.2% volume per volume. Number 2, potassium permanganate. Cyclohexane. Note that cyclohexane is highly flammable and harmful if swallowed. So, dili ta magkanang pabayaan niya ito mga chemical kay it's dangerous. Number 4, cyclohexane. Also, it is highly flammable, skin and respiratory irritant. So, it can cause kanang skin and respiratory irritant. Lastly, number 5, the 100 ml distilled water. Again, reminder, always remember that cyclohexane is highly flammable, harmful if swallowed, and toxic in contact with skin. And cyclohexane is highly flammable and a skin and respiratory irritant. Then our bromine water is toxic and irritant. The concentration should not exceed at 0.2 volume per volume. Then our permanganate solution is just a low hazard. This is a substitute for bromine water for us. So these are the glassware or apparatus that we're going to use in this experiment. Number 1, eye protection, grater, Bunsen burner, heat resistant mat, tripod and gauze, orange, we have 2 orange, 7, 1100 degrees Celsius thermometer, measuring cylinder which can contain 100 ml, measuring cylinder 50 ml, distillation apparatus, 11 250 ml round bottom flask, still head, thermometer packet, condenser, receive adapter, test tubes and bungs, dropping pipette, anti-bipping granules, and oil bath. So before we're going to explain the procedure of extracting limonene from oranges by stem distillation, let's have first to discuss its importance. The peel of oranges is boiled in water and the oil produced. Mo na ang kanang atong gitawag nga limonene. Distilled in the steam at the temperature just below 100 degrees Celsius, well below its normal boiling point. The immiscible oil can be separated. Direct extraction by heating would result in decomposition, whereas steam distillation does not destroy the chemicals involved. Kung ato siyang i-direct distillation, kung ato siyang i-direct o extract, ang result niya kay kanang decompose siya. But kung atong gamiton is steam distillation techniques, limonene is an unsaturated hydrocarbon class as terpene. At room temperature, it is a colorless oily liquid with the smell of orange. Its molecular formula is C10H16, which is yung carbon kay 10 and the hydrogen is 16, and its boiling point is 176 degrees Celsius. This is the structure of limonene. Limonene is a chiral molecule with 2 optical isomers or enantiomers. The major molecule form the limonene. The R enantiomer is used in food manufacture and medicines. It also used in fragrance in cleaning products, abonatical insecticide, and due to its flammability, a potential biofuel. The S enantiomer, L-limonene is also used as a fragrance but has a piney terpentine odor. It is possible for us to observe the optical activity of chiral molecules by comparing saturated glucose solution with distilled water in polometer. Now let's proceed to the procedure. So, for health and safety, we should wear eye protection and gloves for handling the cyclohexane. Step 1. Grate the outer orange colored rind of 2 orange and add to 100 ml of distilled water and 250 ml round of bottom flask and add anti-bumping granules to the round bottom flask. So, itong una pa ito na ni kaya ito ang i-grate ang outer layer sa orange. Katong orange jud sa orange. Ang panit sa orange. And ato add to 100 ml of distilled water in 250 ml round bottom flask. Ato siya ibutan sa round bottom flask. Dayon atong butngan og 100 ml nga water. Dayon ato siyang butngan og kanang anti-bumping granules. Then, set up the distillation apparatus. After na to mag-grate ang orange, then nabutan nato siya sa bottom flask, ato nang i-set up ang distillation apparatus. Dayon, next, heat the flask so that distillation proceeds at a steady rate, approximately 1 drop per second of distillate. Take note, take care not to let the liquid in the round bottom flask boil too strongly. Do not let the liquid boil too strongly in the round bottom flask kay baka madaot imo ang experiment. Then collect approximately 50 centimeter of distillate in the measuring cylinder. The oil layer will be on the surfaces. Di ba napainit na nato ang round bottom flask nga naay sulod nga gigrate nato nga outer orange colored rind. So magbutang daw ta og 50 cm cube nga distillate in the measuring cylinder. Then makita nato nga ang oil daw will be on the surface. Then using a dropping pipette, carefully remove the oil layer into the test tube for the next stage. So after na to makita ang katong oil nga nasa surface, kay ato siyang hinahinayon og kanang kuha gamit ang ato ang dropping pipette aron ibutang nato sa test tube para makaproceed ta sa next stage. For step 2, kanang ang odor, ang atong i-observe here is ang iyahang odor. Cautiously smell the extracted oil by wafting the fumes toward the nose. Do not breathe in directly from the test tube. So, atong hinahinayon og kanang smell ang extracted oil. Dili po ta diretso nga moana sa test tube. Kay dapat kanang careful ta. So, let's have the step 3. Diri na magamit ang ato ang bromine water. Measure out of approximately 1 ml of bromine water into each of 3 test tubes. So mag-measure ta og approximately 1 ml of bromine water, then ato isulod sa 3 test tubes. So atong gamiton diri kay tulo ka test tubes. Then add a few drops of limonene oil to the 1 test tubes. Unsa ni kaning limonene oil? Kato niya ang gi-perform ganina sa step 1. So mag-add daw ta ato og few drops lang into sa 1 test tube. Then a few drops of cyclohexane to another. Sa ikaduha na pod ka test tube kay cyclohexane. And sa ikatulong nga test tubes kay few drops of cyclohexane. Place in the bunks and agitate. If the bromine water is discolorized, the molecule contains double bonds. So naay kanang sign here nga kanang if the bromine water is decolorized, the molecule have double bonds. Then the potassium permanganate 7, which is the 0.001 m, can be substituted for the bromine water for class use. So, ang kaning potassium permanganate so para sa tuang mga estudyante nga kanang mag-perform ani nga activity kay kanang kung broom and water man good dapat kanang kuanta dapat kabalo jud ta unsaon pag gamit but we the student need to know the action of broom and water more. So, additional, the amount of oil extracted varies considerably with the variety, season, and the storage of oranges. However, it's always possible to extract sufficient. The amount of oil extracted, so nagavary gyapon na siya kanang factor nga mag-vary siya sa variety of orange, sa season kung kano sa nato siya kanang gikuha, then the storage of kanang sa orange. So also, do not distill more than 50% of the initial volume of water or solid jam will form in the flask, which is difficult to remove. Then lastly, always use a gauze on the tripod or the orange will burn. So dapat magamit ta perminti og kanang gauze in the tripod kay kanang para ang atong orange dili siya masunog. And lastly, let's have the result of our experiment. Extraction or steam distillation of pure components from a mixture of organic compounds, which is our limonene, was performed. So the bromine water is discolorized, hence confirm that the molecule is contain double bond as compared to cyclohexane. So here we can conclude to the experiment that limonene contains double bond compared to cyclohexane. So if we're going to use bromine water, ma-discolorize ang bromine water dahil nag-confirm po siya nga ang limonene kay double bond siya kaysa cyclohexane. So that would be all for my discussion in activity 4. Thank you for listening.